For decades, the Aral Sea stood as a stark warning etched on the Earth's surface. Where once there had been waves, harbors, and fishing boats, a white, toxic, and silent desert emerged. Ships were left embedded in the sand like steel skeletons. Coastal cities lost their shorelines. The wind whipped up salt, pesticides, and fine dust from a seabed exposed to the sun. Everything seemed to indicate that this catastrophe belonged to the realm of irreversible damage, one of those human errors that reshape the map and leave permanent scars. However, in the far north of that disaster, something unexpected happened. The water began to return. The rebirth of the Aral Sea was not a sudden miracle, nor a complete recovery, nor an exact return to the past. It was an operation of engineering, hydrology, and patience that managed to save a portion of the ancient sea. The story is fascinating because it combines one of the greatest environmental tragedies of the 20th century with one of the most surprising ecological recoveries of the 21st. In the same territory, two opposing images coexist. In the north, fresh water is once again bringing fish, birds, jobs, and hope. In the south, the salt remains spread like a crust over a landscape that seems to belong to another planet. The Aral Sea was located between Kazakhstan and Uzbekistan in the arid heart of Central Asia. For much of the 20th century, it was the fourth largest lake in the world, an enormous inland body of water fed by two rivers, the Amu Darya and the Syr Darya. Its size was so vast that on many maps it appeared to be a true sea, even though technically it was a salt lake with no outlet to the ocean. Surrounding it were ports, canneries, shipyards, fishing villages, and an entire culture organized around water. The Kazakh city of Aralsk lived gazing at the blue horizon. Ships arrived laden with fish. Port cranes moved across the docks. Families depended on an economy tied to fishing, processing, and trade. In the south, Moynak was also a bustling port, connected to a fishing industry that fed thousands. The sea moderated the local climate, sustained wetlands, attracted migratory birds, and maintained a delicate balance in a naturally arid region. That balance began to break down when the Soviet Union launched a massive agricultural project in Central Asia. The steppes and deserts of Kazakhstan, Uzbekistan, and Turkmenistan were transformed into fields of cotton, rice, and other irrigated crops. Cotton was known as white gold, and its production became an economic and political priority. To achieve this, water from the rivers that fed the Aral Sea was diverted through thousands of kilometers of canals. The plan seemed like a demonstration of technical mastery over nature. Where there was barren land, productive fields would appear. Where the climate was harsh, there would be harvests. The problem lay in the hidden calculation. The Amu Darya and the Syr Darya were the arteries of the Aral Sea. By diverting a large part of their flow, the lake lost its main source of water. In a closed, hot basin, where water escapes primarily through evaporation, every cubic meter that stopped flowing accelerated its retreat. The disappearance began silently. First, the sea level dropped. Then the coastline receded. The docks became too high. Boats had to sail farther and farther out. Over the years, the sea fragmented. Salinity increased as the water volume decreased while salts became trapped. The fish that had sustained the local economy began to die. Factories closed. Fishermen lost their livelihoods. Port cities were left stranded on land. The most famous image of the catastrophe was that of rusting ships in the middle of the desert. Those vessels looked like the wreckage of an impossible shipwreck. They had been built to float, but ended up surrounded by sand. The coastline retreated dozens of kilometers. The former seabed became a new desert called Aralkum. The name contained a bitter paradox, the desert born from the sea. Aralkum began to act as a source of dust. The wind stirred up particles of salt, sand, and agricultural waste accumulated over decades. The rivers had carried fertilizers, herbicides, and pesticides from the cotton fields to the sea. As the water evaporated, many of these compounds were deposited on the dry riverbeds. Later, storms spread them over villages, crops, and people's lungs. Salt fell on the fertile land, reducing its productivity. The population suffered respiratory problems, pollution-related illnesses, and a profound decline in their quality of life. The disaster also transformed the local climate. With a vast body of water gone, summers became hotter and winters colder. The sea no longer moderated temperature extremes. Humidity dwindled. Dust storms increased. The region entered an environmental spiral where water loss fueled new problems, and those problems further weakened human life around the former sea. As is often the case with landscapes that change too rapidly, dark explanations emerged. Some imagined tectonic faults swallowing the water. Others spoke of secret tests, underground tunnels, or hidden plans to drain the basin and access buried resources. The phenomenon seemed so enormous that a single cause was difficult to accept. However, the main explanation was right in front of us. Rivers had been diverted, canals were losing enormous quantities of water through seepage and evaporation, and the Aral Sea was doomed to evaporate faster than it could fill. By the end of the 20th century, the magnitude of the collapse was clear. Saving the entire sea had become a monumental task. Restoring the Aral Sea to its original state would have required returning enormous volumes of water to the basin and drastically reducing agricultural irrigation in several countries. This would have meant transforming entire economies, modifying farming systems, rebuilding infrastructure, and resolving regional water conflicts. A comprehensive solution seemed unattainable. Then a more limited, but far more realistic, idea emerged: saving the northern Aral Sea. The northern Aral Sea, also called the Little Aral Sea, was located in Kazakhstan and received water from the Syr Darya River. It was much smaller than the original Aral Sea, but it had a crucial advantage. If a barrier were built between the northern and southern parts, the Syr Darya's water could be retained in the northern basin instead of flowing out into the lower, drier areas to the south. The idea was akin to closing the drain of a giant bathtub. The goal was to conserve enough fresh water to stabilize the water level, reduce salinity, and allow life to return. Before the grand project, there were more fragile local attempts. Fishermen and laborers built makeshift dikes with sand and earth. These were barriers born of urgency, constructed with limited machinery and a great deal of desperation. Some held for a while. Then came floods, storms, or leaks, and the water breached the wall. Each failure reinforced the feeling that the sea was lost. The big difference came with the Kokaral Dam. Completed in 2005, this structure, some 13 kilometers long, physically separated the North Aral from the South Aral. The dam and the associated improvements to the management of the Syr Darya were part of a project intended to control the flow and protect the northern basin. Visually, it looked like a concrete line in the middle of a desolate landscape. Hydrologically, it was an intervention capable of changing the fate of an ecosystem. The effect was rapid. The level of the North Aral rose much more than expected. The water's surface expanded. Salinity decreased. The constant influx of fresh water altered the lake's chemical composition. Where the high salt concentration had suffocated many species, an environment suitable for freshwater and brackish waterfish began to form again. Nature responded with a speed that surprised even specialists. The fish returned. First, more tolerant species survived, such as the flounder introduced decades earlier to withstand high salt levels. Then came species associated with the river and less saline waters, such as carp, zander, and other fish important to commercial fishing. The ecosystem didn't need a complete artificial reconstruction. It needed the main pressure corrected. As salinity decreased and the water stabilized, the food webs began to reorganize. The return of the fish meant much more than an environmental fact. In the northern villages, it meant work. Nets made sense again. Small boats started moving once more. Processing plants could reopen. Fish returned to the markets. The recovery of the North Aral showed that part of the disaster could be reversed with a well-directed technical decision. The change also had an emotional value that is difficult to measure. For years, the nearby communities had lived surrounded by symbols of loss: rusted boats, dry docks, salt dust, and abandoned houses. The arrival of the water brought a different picture. Birds returned to certain areas. Fishermen resumed an ancestral trade. Children were able to grow up with a real sea near their villages, even if that sea was smaller than the one their grandparents had known. The story took on an almost mysterious tone because it seemed to contradict the usual narrative of environmental catastrophes. In many cases, the damage worsens and repairs come too late. In the North Aral Sea, partial restoration showed visible results within a few years. Satellite images allowed the change to be observed from space. Where there had once been retreat, there was now expansion. Where the coastline had receded, water began to fill ancient depressions. The planet showed a scar that, at least in one area, was beginning to heal. The South Aral Sea followed a different path. There, the Amu Darya, its main historical source, continued to be subjected to enormous pressure from agricultural irrigation. The southern part of the sea fragmented, shrank, and in large areas almost completely disappeared. In some years, certain basins received water temporarily from rain, runoff, or changes in flow rates, but the overall trend was much more severe than in the north. The contrast became stark. On one side, the water was returning. On the other, the desert was advancing. This contrast makes the Aral Sea a complex lesson. The phrase, "the Aral Sea is returning," contains both a truth and a limitation. It is returning in the north, where geography, engineering, and the flow of the Syr Darya allow for a partial recovery. The entire Aral Sea, that giant of the mid-20th century, remains fragmented and significantly reduced. Most of the former basin is still affected by desiccation. The return is happening, but it pertains to a specific portion of the former sea. The southern part also holds one of the most unsettling chapters in history, Vozrojdeniya Island, known as Renaissance Island. When the Aral Sea was full, this island was isolated by water. This isolation made it an ideal location for secret Soviet facilities. A site linked to biological testing operated there for decades. Its existence fueled rumors, fears, and theories that grew when the sea receded and the island ceased to be an island. Upon joining the mainland, the former isolation vanished. The scene had all the elements of a post-apocalyptic mystery. Abandoned laboratories, empty buildings, tracks and polygons in the middle of the desert, a ghost town called Kantubek, animals capable of crossing from the mainland, and wind stirring dust over facilities that had remained hidden. For many, the question was inevitable. What lay buried in that place? The official, scientific answer was less cinematic, though equally serious. After the site's closure in the 1990s, international teams participated in inspection and decontamination efforts. The area's extreme environment, with intense heat, solar radiation, aridity, and winter cold, favored the decomposition of many biological remains. Even so, the site became forever associated with the darkest dimension of the Aral Sea, an environmental catastrophe that, as it dried up, also revealed 20th century military secrets. Another secret of the dry bed lay in the salt itself. The bottom of the Aral Sea was no ordinary beach. It was a chemical archive. For decades, it received runoff from intensive agriculture that relied on fertilizers and pesticides. As the water receded, this mixture was exposed. Dust storms carried particles over vast distances. The white sand wasn't just sand. It was a material laden with agricultural history, political decisions, and health consequences. To stem this dust, a seemingly humble strategy was developed, planting vegetation in the dry bed. One of the most important species is the saxaul, a desert shrub or small tree capable of surviving in extreme conditions. Its roots anchor the soil, reduce erosion, and help prevent the wind from carrying away contaminated particles. Mass planting of saxaul acts as a biological shield. Where engineering built a dam to save water, ecological restoration plants roots to hold the soil together. This combination reveals a central idea. The recovery of the Aral Sea depends on many scales simultaneously. A dam changes the level of a watershed. A repaired canal improves irrigation efficiency. A saxaul forest reduces dust storms. An agricultural decision in a distant valley determines how much water reaches the sea. The catastrophe was born from a whole system, and the repair also requires a whole system. The Kokaral Dam was just the first major step. Kazakhstan has proposed further phases to raise or modernize infrastructure, increase the level of the North Aral Sea, and bring water closer to Aralsk. The once prosperous port city still retains symbols of its maritime past. Its old cranes and port structures are reminders that the water once reached this far. Today, the shoreline is closer than during the worst years, but the old port has not yet fully recovered. Many residents dream of seeing the water return to the docks. Raising the level of the North Aral Sea would increase its surface area and volume. It could also improve ecological stability and expand fishing grounds. However, every additional meter requires precise calculations. Available water remains limited. The Syr Darya also sustains agriculture, cities, and ecosystems upstream. Restoration must balance human needs, infrastructure, climate, and regional cooperation. In Central Asia, water is simultaneously an environmental, economic, and political issue. Climate change adds another layer of pressure. The mountains of Central Asia feed rivers with snowmelt and glaciers. As temperatures change, so do patterns of snowmelt, drought, and water demand. Agriculture requires increasing efficiency. Open canals lose water through evaporation. Old irrigation systems waste valuable flows. In this context, the future of the North Aral will depend on both new infrastructure and smarter water management across the entire basin. The case of the Aral Sea also exposes a profound tension between production and ecological survival. Cotton provided income, jobs, and economic power, but its unchecked expansion transformed an entire watershed. The central question is not solely about historical blame. It revolves around how a society calculates the true cost of its decisions. Water diverted to a field may produce a harvest for a season. Water that no longer reaches a lake can destroy a fishing economy, alter a local climate, and create a toxic desert for generations. The partial recovery of the North Aral demonstrates that nature retains a remarkable capacity to respond. When it receives sufficient water and tolerable conditions, life seizes every opportunity. Species recolonize, wetlands revive, birds return, local economies can reorganize. But that capacity has limits. The South Aral starkly illustrates those limits. Some damage becomes extremely difficult to reverse when scale, dry weather, economic interests, and decades of accumulated loss are combined. That is why the return of the Aral Sea is so powerful as a symbol. It does not represent a complete victory over disaster. It represents a partial victory against resignation. For years, the Aral Sea was cited as an example of irreversible collapse. The Kokaral Dam and the recovery of the northern Aral Sea changed that narrative. They showed that a part of the system could be saved. They showed that a well-designed intervention could produce visible results. They showed that even a devastated landscape could hold the potential for rebirth. History also reveals the importance of reading maps accurately. To say that the Aral Sea disappeared is an oversimplification. To say that it returned completely is also a distortion of reality. What happened is more complex and more interesting. The ancient sea fragmented into several bodies of water and new deserts. The north stabilized thanks to the dam and the Syr Darya River. The south lost much of its surface area and remains in a critical situation. Between these two extremes lie fluctuating zones, wetlands, canals, projects, ruins, villages that are returning, and villages that were left too far from the water. It is in this complexity that the story takes on an almost detective-like tone. The dry seabed functions as a scene where every element tells a story. A rusted ship reveals the speed of its retreat. A crust of salt tells of evaporation. A cotton field tells of the river's diversion. A dam tells of the decision to save a portion. A fish returning to a net tells of the reduction in salinity. A ghost town on a former island reveals the secrets of the Cold War. The Aral Sea is not just a place. It is an open archive on the relationship between engineering, power, water, and time. The Soviet engineering that diverted rivers was born from a vision of conquest. The Kazakh engineering that saved the North Aral Sea was born from a vision of restoration. Both altered the landscape. The difference lay in the objective and the scale of their consequences. The former treated rivers as pipelines serving mass production. The latter treated water as the minimum condition for reactivating an ecosystem. This difference encapsulates one of the great lessons of the Aral case. Technology amplifies human intention. It can destroy with enormous efficiency, or it can repair with surprising precision. The return of water also reshapes memory. Older generations remember a vast sea, bustling ports, and abundant fishing. Generations that grew up during the desiccation remember dust, unemployment, and dead ships. Newer generations in the north may know a different Aral, smaller, protected by a dam, dependent on technical decisions, but alive. This shift in memory has enormous social value. A territory that inherited only loss is beginning to inherit recovery as well. The future remains open. If the modernization of the dam and the management of the Syr Darya River progress, the North Aral could gain more land and move closer to Aralsk. If agricultural pressure increases or droughts reduce flows, the recovery could stall. If Saxol plantations thrive, dust storms could lessen in some areas. If regional cooperation improves, water can be used more efficiently. Each variable influences the sea's fate. Most importantly, the North Aral has already demonstrated something that for decades seemed improbable. A continental-scale environmental catastrophe can contain areas of reversal. Recovery requires first accepting the physical reality of the problem. The water disappeared because the rivers were diverted and evaporation did the rest. The partial solution worked because it returned water, reduced losses, and created a manageable watershed. The explanation isn't magical, but its result seems miraculous when compared to the previous landscape. In the far south, rusting ships continue to tell another part of the story. Some have become tourist attractions, others were dismantled for scrap. The old port cities hold memories of a lost coastline. There, the return of the entire sea belongs more to the realm of dreams than immediate plans. To refill the entire basin would require an immense regional transformation. Agriculture, the economy, and water policy would have to be reorganized on a scale difficult to imagine. But the value of the North Aral does not depend on returning everything to the past. Its value lies in demonstrating that partial restoration also matters. Saving a part of an ecosystem saves livelihoods, species, wetlands, local economies, and memory. In a world accustomed to thinking in terms of global catastrophes, the Aral case teaches that environmental victories can be incomplete and yet decisive. A smaller lake can be the difference between a dead region and a region with a future. The Aral Sea began as a victim of human ambition to control water. Then it became a symbol of neglect. Today, in the north, it has been transformed into a laboratory of recovery. Its history contains both warning and hope in the same image. The warning lies in the Aralkum River, in the salt, in the pesticides, in the cities cut off from its shore. The hope lies in the Kokaral Dam, in the fish that have returned, in the fishermen who have gone back to the water, and in the projects that seek to bring the sea closer to Aralsk. The Aral Sea's deepest mystery lies not in a secret crevice or an invisible tunnel. It lies in the speed with which a natural system can collapse when its equilibrium is disrupted, and in the speed with which a part can respond when its essentials are restored. For years, the dry seabed seemed like a final sentence. Then, the water pooled behind a dam showed that the story still had another chapter. The Aral Sea has begun to return, but its return does not erase the catastrophe. It illuminates it. It shows precisely what was lost, what can be saved, and what requires constant vigilance. The ancient giant of Central Asia is no longer the same. Its southern part remains scarred by desiccation and dust. Its northern part, however, breathes again. There, fresh water advances over territory that had been surrendered to desert. Nets are being cast once more. Fish are moving again. Birds are finding refuge once more. On that border between ruin and rebirth lies the true power of this story. The Aral Sea teaches that nature can forgive some mistakes when given space, water, and time. It also teaches that every restoration comes with limits, and that every limit forces us to make wise decisions. The return of the northern Aral Sea is not the return of a completely lost world. It is visible proof that even one of the worst ecological catastrophes in history can contain a zone of life waiting for the right opportunity to return.